I live in Southern California. When I was growing up, living in Lakewood, if it would be 85 degrees, my friends and I would hop in the car and then we would drive down to Newport Beach. We'd arrive at Newport Beach and it would be 65 degrees. We'd drive back to Lakewood and it would be 85. I'd call my relatives in Ontario, California, and it would be 100. What's the difference between these places? Latitudinally, they're at about the same latitude. The difference is their relationship to water. There's something called the land-water rule, and it's made up of 3 sentences. The first one is, land surfaces are rapidly and intensely heated under the sun's rays, whereas water bodies are only slowly and moderately heated. Land surfaces cool off more rapidly and reach lower temperatures than water bodies. Temperature contrasts are therefore generally great over land and moderate over water. Let's take a look at this not very good diagram, but it actually explains something very well. Water bodies, which cover about 75% of the surface of the planet, act as climatic modifiers. That means that it doesn't get really hot and it doesn't get really cold. There are several reasons. This diagram shows them on the left-hand side. As we know, when the sun's rays come in, if the sun strikes the water body at a low angle, water bodies have a high albedo, which means the energy gets reflected. If the energy is being reflected, it's not being used. Additionally, water bodies, of course, evaporate. Evaporation is a cooling process. It's a cooling process for whatever the water is evaporating off of. You have probably come up out of the water from a pool or the ocean or a lake or whatever it may be, and you get hit by a breeze and you feel your body cooling off. What's happening is this. Water is evaporating off of your body. When that happens, the water is switching from a liquid to a gas. In order to do that, the water molecule has to absorb energy. It gets that energy from you. And then the energy is transferred from your body into the atmosphere, causing you to lose energy, thereby cooling off. Furthermore, water bodies are transparent. You can see through them. The sun can see through them. And in fact, in the ocean sometimes, the sun's energy will transmit down to a depth of 200 feet. Remember, the game is concentration versus dispersal. So what happens because water bodies are transparent is the sun's energy is able to penetrate deeply into the water body. When it does that, it's heating water molecules the whole way, which disperses the sun's energy. You have probably also been out swimming with a friend, and you're looking straight at your friend, and from the direction of your friend, you feel a burst of warm water. Come on, that's not coming from the interior of your friend's body. That's because water mixes, and warm and cold waters, when they mix, further transmit the sun's energy, which is greater dispersal. In addition to that, water has what's known as a high specific heat. Specific heat describes the amount of energy that's needed to heat something up. In the terms of water, water has a specific heat of 1. That means it takes 1 calorie to heat 1 gram of water, 1 degree Celsius. Now this is pegged to water. Like many things are pegged to water because we understand it. 0 degrees Celsius is where water freezes. 100 degrees Celsius is where water boils. All of this is called the maritime effect or the maritime influence, which describes the moderating effect of water bodies on climate. The reason water bodies act as climatic modifiers is because of those things I just discussed. So if you live near a major body of water, it doesn't tend to get as hot nor as cold as if you lived inland. Let's look at land masses. Well, land masses go through the same processes, only in a way opposite. So with land masses, what happens is there's very little reflection, as we know. In addition to that, of course, dirt does not evaporate. Yes, water evaporates out of dirt, but if the dirt is dry, the dirt itself will not evaporate, which basically stops cooling. Can you see through dirt? Neither can the sun. There's no deep transmission of the sun's rays, so all the energy is concentrated. At some point, you have probably gone to the beach, you saw your friend 50 yards away on the beach, and you started walking across the beach, and you had forgotten your flip-flops. Pretty soon, you're no longer walking across the beach, you're running to your friend because your feet are burning up. The reason is because the sun's energy is concentrated in the top inch or 2 of that sand. When you reach the towel and you dig down into the sand, you see that 4, 5, 6 inches down, it's not hot there. So this is all about concentration of energy because there's no deep transmission. Furthermore, there's no mixing. Have you ever been sucked down 200 feet in the dirt and then thrown back up? No, the dirt's not mixing at all, unlike water. And soil, dirt, land, whatever you'd like to call it, has a low specific heat. It's about 0.25. In other words, it takes about 0.25 of a calorie to heat 1 gram of soil 1 degree Celsius. If you applied an entire calorie to 1 gram of soil, 1 calorie would heat 1 gram of soil 4 degrees Celsius. So land doesn't need nearly as much energy in order to heat it up. Because of that, temperature and climate extremes exist in the middle of land masses. We call this the continental effect or the continental influence. It means that inland areas tend to get much hotter and much cooler than coastal areas. Let's take a look at these 3 places: San Francisco, Sacramento, and Memphis. The blue bars are precipitation. Don't worry about those. Look at the red lines. Notice that both Sacramento and Memphis have much greater arc to their temperature graph, whereas San Francisco's is a bit flatter. Let's see where these places are. San Francisco, of course, is the famous city by the bay. Sacramento is inland, and Memphis is inland. Now let's look again. San Francisco has a moderated climate because it's right next to the Pacific Ocean, whereas Sacramento and Memphis are both inland areas and they experience greater extremes in temperature.